Cool. Let's see here. Let's get started. I don't know if this is going to take the full 45 minutes. If it's not, we'll just wrap up early. We'll see how it goes. But great. This is JavaScript and parallel processing. My name is Joe Karlsson. I'm actually currently technical lead for BestBuy.com. So I'm hanging out at Best Buy on my day off, which is fine. This is fun. Those are my socials. If you want to follow me, I post a lot about JavaScript, front-end performance, security, empathy and tech, that sort of stuff too. If you want more of that stuff, that's great. And yeah, other things, I also Twitch stream twice a week. I do live coding twice a week, if you want to check that out. And I do a lot of tech talk, so I travel on the world and talk about technology. This is kind of my first time doing this one. I'm going to be doing this one. I'm going to start touring with this one soon, so any feedback after this is really greatly appreciated. Yep. All right, that's me. Cool. So how's this gonna work? This is like a more small, intimate, session. So I really prefer if you guys ask questions like while we're on something. I will have time at the end for questions. I'm gonna just kind of keep rolling. But if you raise your hand and yell, let's address it. I don't know. I'd rather do it while we're in it than like come back to it. So it doesn't disrupt my flow or anything like that too. I will be posting these slides on my Twitter afterwards, along with all the code samples and additional resources on there too, so you can get all that on there. Okay, I think that's it. Cool, so let's just get into this thing. So JavaScript and parallel processing. So did anyone know you could do parallel processing with JavaScript? A couple maybe heard of it. Yeah, which is kind of weird. So let's talk some getting into what it is, how to do it, and all the weird quirks that you get with doing parallel processing on it too. So we do need to go through some background though, just kind of get us all on the same page. So first of all, we got to talk about single threads, what they are, and how we got here, and then we can get to the future. But so JavaScript has been originally designed to use single threads. It's been that way since whatever, when it was invented, like 93 or whatever. And it's only been recently that we've been branching out into multi-threaded models. So, what is a thread? Can anyone tell me what a thread is? I have a guess.
A single line of execution with a constrained memory space.
Yeah. So, and like, has anyone ever heard of like multi-core, quad-core, right? Right, most computers have multiple cores on them, and each core is capable of handling a single thread at a time. But if you can utilize multiple cores, you can break up work and accomplish stuff faster. By default, JavaScript in the browser utilizes a single thread, which is cool, but also has some performance reasons why it was. So I want to talk about first why JavaScript is originally designed to be single-threaded and what benefits we get out of that too. So first of all, let's see here. Now, how many JavaScript developers do we have right now? I'm assuming probably most people are at least vaguely familiar with it. Cool. So first thing, the first reason was JavaScript was originally designed over a weekend project, and it was just intended to be kind of like a minor scripting language to handle form validation. And it's kind of ballooned into this massive beast that we are currently dealing with today. But one of the biggest benefits of using a single thread is you don't have to manage race conditions, threading. Everything kind of executes as you program it, and you're not going to have any weird surprises in there, which is great. That's totally fine, right? Like, it makes our lives easier handling that, and it's an abstraction layer we don't have to worry about. Handling single threads also make it easier to debug and test your code, right? Race conditions, things may finish on threads earlier than you expect. Things don't mess around. If you've dealt with multiple-threaded programming languages, like most programming languages, Java, Ruby, C#, right? You're going to have to handle testing and validating race conditions, which are hard to reproduce. Easy to port code, right? So handling multi-threaded code really depends on the hardware you're putting it on. So for example, I'm designing code that can handle a GPU with like 1,000 concurrent cores. I can't port that over to my cell phone. But single thread, you can port that over anywhere. Anything that has a CPU, you can port that code over, it's going to work. You know, it's not dependent on the hardware. Also, handling single thread is actually faster in some events. So that's actually one of the big reasons Node is a big deal. So Node was a revelation because it's one of the first server-side frameworks that utilize a single core single thread using the event loop. It's not to say that it doesn't use multiple threads, but the event loop is single-threaded. And it was an experiment to see what happens, and it ended up being faster for really fast I/O events. So that would be, for example, Node is a really great server-side framework for events that just like a request comes in, you don't have to do much calculation on it, and it just kind of sends it out right away. Messaging, IMs, web streams, quick just data events. But it wouldn't work well for something like maybe like a tax software or some sort of like data analyst, something that has to do heavy server-side rendering on it, that blocks the cores and causes issues, and not a good fit for it. And lastly, not many people know this, but single threads can do everything multiple threads can do. It just does it in a different way, or sometimes slower. So there's a lot of great reasons to use it, and we've benefited from a lot of those in JavaScript and Node, which is awesome. So, the question is, what's the problem? Why would we want to start introducing multiple threads into the browser? We're just like we're gonna make our lives worse, right? But the big reason is that the single thread by the browser is shared across all events, all files in the browser. So, put another way, if you have a program in the browser or code, JavaScript code that's running in the browser, and it starts running, starts utilizing that single thread and maxes it out, it's going to block everything else. So really data-intensive stuff, it starts blocking what users can do. And I'm going to demo this in just a second, but for really data-intensive browser code, you can actually, it blocks all events. You can't even click on stuff, alerts don't work, everything gets totally blocked up. And multiple threads allow us to kind of break that work up so that we can still like use the website even if it's doing really data-intensive work. So, examples. Let's see here, does anyone know, what would be some examples of stuff that might take a long time in the browser? What's that? Prime factorization, sure. So like really data-intensive math functions, yeah.
I read the TensorFlow JS docs the other day, and they had a line that said, if you use this in the browser, it will block the main thread.
Yeah.
We recommend you use web workers. So.
Perfect, yep, exactly, yep. Yes, and that's like machine learning software, which browsers does not excel at handling. But some other things that you might have encountered as well would be a lot of things that we do on the front end are like retrieving data from an API. And if that JSON set is humongous and we have to parse through that on the front end, that can gum up the front end. I'm actually going to show you this exact example. Some other ones would be image processing. Maybe you have like some sort of edge detection, client-side edge detection software in a photo that you want to do before you send off to the client. That's going to be super data intensive. Sound processing, if you're doing any audio analysis on the browser, like building like a Spotify client or something like that, you're going to be probably going up that main thread. Any video and then any real-time analytics in the browser is also going to be really data intensive for that main CPU thread. So I want to demo what this looks like to gum up the main thread and why it's a problem. So I've written a pretty simple little function. So all it is just a massive for loop. And then once it's done, it's just going to print the DOM that it's finished. And I have a button on here that's just going to start the loop. And I also have a button on here that's going to just say it's going to cause an alert. So let's take a look at this. I have this. I'm on the other. Okay, so this is our slow big loop. So you'll see here, when I start this big loop, I'm going to try to hit this alert, right? But it's running that for loop behind the scenes. I'm hitting say hello, and nothing's happening. By blocking the main thread, I've totally blocked the user from doing anything on my page. And look at this. So now the main thread it's added that to the call stack, and now we're going to see all those alerts come through all at once. Right? Yes. Yeah, hopefully. I haven't done that one yet, but next. And now it's done. So, I mean, this could be, we're building like interfaces for users. And if we start designing data-intensive application on the front end and it starts blocking the user from actually doing work, that's a massive problem. And we need to start figuring out how to do that. So, yep, no good. Gotta put my cursor. Great. So this problem is bad. I'm on a MacBook Pro, and this is still an issue, right? This problem's even worse on mobile devices for web apps. It's going to take longer. It's going to block up more, right? Even worse. So, how do we deal with this? So, web workers, right? We already got. We know we're going to be going web workers, but let's say, for example, what did we do before web workers existed? Does anyone know how we solved blocking issues like this?
Set timeout.
Set timeouts, could do that. So that's like a hack for kind of getting on different threads. That's actually a good point.
Promises?
What's that?
Promises?
Promises. They still, well,
So-
kinda. Yeah, they may still gum it up. Yeah, but and promises are still pretty new too. Yes, yeah. So that's mostly what we would do for data-intensive applications. And there's really nothing wrong with that. People do that today. If you have massive server farms that are capable of handling massive data calculations, offloads, and that work with the client, cool, no problem. But with anything, there's a cost. And you should be aware of what you're trading to do that. And if you guys are familiar with this, these are numbers everyone should know. If you're studying for big interviews, these are great numbers to memorize. But you'll notice that we have let's go ahead my mouse here. Yeah, round trips, right? Round trips to different servers is much more expensive time-wise than it is to just call some data from memory. So if we can save a round trip, we can make a more performant application for our users. And it's nothing wrong that sometimes you do need to offload that server. Totally fine, no worries. But if you can still make a super fast application that doesn't block up the main thread, still usable on the browser. All right, cool. So servers, still an option, but web workers to the rescue. So web workers are, well, let's get into it. They allow us to do multi-threading in the browser. So what they do is it basically allows us to designate JavaScript files that we want to run on a separate thread. Okay, so benefits of this: it's faster. It's going to be more responsive. You don't have to make a server request. You can just pulling that data from memory the second it completes in the browser. This can be more battery efficient too. And if you notice too, but sending data, opening up a channel to talk from a mobile device to a data center too is really battery. Because it zaps your battery quite a bit opening up that
TCP connection?
Yeah, open up the initial TCP connection on your phone. Battery efficient. And lastly too, this part actually surprised me until I started working on this talk. It's actually supported in every major browser since IE10. So this has been around for a long time now, and you can use it pretty much everywhere. I am going to be showing you how to do polyfilling and handling browsers that don't support it, but it's pretty ubiquitous right now on mobile and desktop support. Cool. Okay.
Is there a reason why they say it's not deprecated, but no, experimental in Node still? Maybe not the most recent version, but like.
So Node's a little bit different. Node's handling, they're called child processes, and it's a little different idea in Node. But yeah, Node is starting to foray now into multi-threading. Yeah, but it's a little bit. I don't think they're doing that via web workers, or are they? I don't know.
I can't remember.
I know they're doing child processes, but which is a little bit different. Yeah, I think they're still working on it too. And Node and JavaScript, they just joined this last November in a single like consortium or whatever. But they've been two separate entities kind of doing their own work. So if just because one's supported in the browser or in JavaScript doesn't mean it's supported in Node yet. But now, hopefully it should be better. I'm trying to sync it up again. Cool. So let's get into the weird. I want to get into the weird parts about web workers, and then I want to show you how we can fix that initial demo to use web workers to kind of unblock that main thread. So first of all, this is weird. Web workers cannot directly access the DOM or window object. This part surprised me. So from the main thread, like we're used to writing JavaScript files, we can access like window dot whatever, or like document dot some sort of object on the DOM. You actually can't do that.
Can you get the local storage?
Maybe. We have access to a lot of stuff you can do on the main thread, but it is limited. You might be able to, but I have to check. Good question. Cool. So I think this makes more sense if we get into how they actually work. But this is the example of how you instantiate a new web worker in your code. So all we're doing is just running new capital W worker, and then you just run that whatever JavaScript file you want in it. And what that will do is it creates a brand new web worker for every single, or it creates a brand new thread for every web worker you have. So one web worker equals one brand new thread. Cool. Let's see here. I'm going to show you. Well, I'm going to give it. I know I have this here, but this is actually code. Someone wrote a password cracker in the browser, and it's running. You can actually see all the separate worker threads it's created too. I'm going to show you that code in just a second.
Does it just automatically run the code you give it?
Yeah, so you control the flow.
Okay.
You control the flow, and I will show you how that happens actually. Web workers work by communicating, because you don't have access to the main, like the DOM in the window, but you need to send messages back and forth to the main thread in order to do that stuff. And we do that via messages, and think of them just as like fancy events. This is actually what they look like. So in our main thread, we create that new worker, right? Worker equals new worker, JavaScript file, and then we wait for onMessage. And onMessage is basically some sort of message we're getting from that separate thread, and we're communicating that back to the main thread. So once we get that message that thread is completed, we can throw that over. We can also handle errors that too, on error, undone. Cool.
Can you show, or are you going to show how that, like, how you fire that event up?
Yes. Yep. So I'm gonna skip ahead here too. So let's take a look at what the real code looks like. Oh no, it's the wrong one. Let's see here. On message. Actually, you know what? I'll tell you what. Let's just look at my real code here. And fast. Okay, so we have our same examples before. I'm doing some fancy checking here too, which we'll get into in just a second. But we have our onClick function, which is start worker, and then we're going to invoke that function. Whenever that gets invoked, we do some check to make sure the browser supports it. If it does, we're going to instantiate a brand new worker. And then we have an asynchronous event here, that message queue, and we just wait for our threads to kick back at us. And then I can show you what that code looks like as well. So we have our big loop. All I've done is kind of pulled that big loop from our main thread into a separate worker file. And I can take a look at that over here. And it's pretty simple. You communicate back to the main thread with a function, just post message, and whatever you put there will be passed through to the main thread
As
data.
message, right?
Exactly.
On message.
Yep, exactly.
Can you reuse the same worker over and over?
Yes. Yep, absolutely. Yep, totally. Yeah, if you wanted to so you could have it have 8 workers go out and try to find something, and the first one that finds it comes back to the main thread and can terminate all the other threads.
Cool.
Yep.
Can the message be of any type of data?
Yeah.
Metrics,
Yep. It could be a function, it could be a callback function, it could be whatever. Yep.
Okay.
Yep. It's like a vanilla function. This still blows my mind. Like, we don't need any other third-party libraries. This is for free. We just get this in the browser. Yeah, maybe I'll show you. You know what, I'm gonna show you the fancy one later on. But okay. Let's see here. Let's jump back in. Okay, actually, you know what? I'll just show you the code here. We got to the code. We have our fast big loop here. So a couple things under sources, you can actually see threads that are being created by the browser. So I'm going to show you on this one. If I do start big loop, I gotta refresh here. Oh, it's blocked. Okay, I'll switch over here. We'll start over here. It's still going. But you can see this code's still running on the main thread here. But I'm going to run the start worker, and it's going to instantiate a brand new web worker and a brand new thread. And you can actually see that get created in real time here under Chrome DevTools. So when we start worker, you can see big loop is created. And it pulls it off the main thread once that completes, and that message is terminated. So once the post message, think of it as like a return for web worker. It'll kill that thread for you once it sees that post message
Really,
back to the thread.
it kills it. So
Mhm.
you can't just like have a bunch of post this, and then maybe more work is done, post this.
You may want to create different ones, and you may be able to. Yeah, as far as I know, I think you can't keep doing work on that thread once you've like communicated it back, which may be good too, because like it keeps your threads like small and focused too.
You'd end up with like a zombie thread at some point.
Yeah, you could have like memory leaks.
You'd send something off, if you don't respond to it, it's just going to sit there and eat up your memory, and then you won't be able to close the tab, and it's going to freak out.
Yeah.
Well, you should still be able to close it because the browser should be safe in that respect. Just like if you have an alert window open.
Hopefully, yeah. I mean, hopefully, yeah. And Google's pretty good about garbage collecting and closing stuff that it deems as a zombie. Yeah. But let's take a look at that again. So I didn't show you this either. So when I do start worker, it still frees that main thread. It's still free for me as a user of the application to still interact with it. So remember before on slow big loop, when we clicked that start loop, we couldn't use that alert button anymore. Now when we run the start worker, we can still use the main thread to interact with the web page. So it wasn't completely blocked like it was before. Right. Let's see here. Let me restart this.
It may have optimized it.
And we can still go, even though the thread's still in the background. Cool. Cool. All right. Let's see here. So let's jump back in. So we've gone over how to instantiate one. We've gone over the message queue system, so how to communicate from a separate thread to the main thread. But let's go over terminating too. So sometimes, I gave the example too, maybe you instantiate like 8 different workers, and you want them all to go race to figure out what the right answer is. Once you get the answer, it's a waste of resources to keep those other threads open. Maybe you want to close those right away. So how do we tell a web worker that they're over the line, they need to come back home? Well, we do that with just tell it to terminate. It's pretty simple. I have a button on here too that just runs a function that terminates the thread. And then I'm kind of pulling that off of, I'm deallocating that worker namespace so we can kind of reuse that again or whatever we need to do.
What would happen if you just set worker to undefined out worker.terminate?
I think it would say terminate is not a function of undefined probably. And I don't know if it would terminate that thread.
I was just kind of curious.
Usually the V8 engine's really good at garbage collecting and seeing if like no one's pointing to a reference anymore. It usually figures it out. I haven't tested it though. I'm guessing your coded error out the second after it gets that worker.terminate though. But the thread may keep going until Chrome determines it's ready to be pulled off. Cool. And see here, I think I have a little demo here too. I always do GIFs or videos just to like keep track of. Oh, there it goes. I had to click it twice or something. But yeah, stop worker terminates that from the thread even though it hasn't completed yet. Cool. And errors. We went over this briefly too, but we need to make sure we're handling our. If an error gets thrown, we need to make sure we can handle those well. Yeah, it's yeah. I mean, if it's programming, something always goes wrong. We want to make sure we're always handling that, right? Maybe a worker got, I don't know. We want to make sure we handle those. So with workers, if any error happens in any of your or in that worker, you can bubble them up through the worker.onAir listener, and this is a click event that listens for that too. Cool. So start, stop, handle errors. Great. One last important thing too. That's checking for browser support. So, like I said, it's handled in most modern browsers, i.e. 10 plus, but it's still a good idea to do a wrap around it to make sure that, do a check to make sure that that worker exists. Yeah, to make sure that your browser's cool. So the way we do that too is we do a check to see if worker exists. So we just check to see if worker is in fact a defined class in the browser, and it does not equal undefined. If it's undefined, it means the browser has no idea what you're saying when you're trying to access this worker class. And then we're doing a check then. So if that's supported, we do a check to see if that worker has been allocated or not already. So do we already have a worker defined? And remember when I terminated, I just reset our. You don't have to do that, but it's best practice with dealing with web workers to kind of deallocate that. And yeah, cool, awesome. So web workers. Let's see here. Any questions so far before I go into like future? Let's see. Yeah.
How do you pass data into it? I get that you can just call a JavaScript.
Yes.
But like, how do you say, like passing arguments to a function, kind of like that? Otherwise, it's not really powerful.
Good question. Let's see here. Actually, I'm not exactly sure.
Because it can't get at the DOM.
You may be able to like, post a message in there. I'm not sure. I'll have to look that up. That's a good question. Yeah. Yeah, good question.
So prior to the on message is basically what you're looking for.
Yeah.
Something prior to
Or
that.
something to pass into it. Yeah.
Yeah.
And I'm guessing you'd
If
probably
it's-
do that when you instantiate that, but I'm not sure you can pass that in. I'd have to look it up.
Okay, it's cool.
Yeah.
I've got kind of maybe a follow-up on that.
Yeah.
Say you want to offload some process to the web worker, and you're building your application, and you're importing a bunch of NPM modules in, and some of the work you're doing is dependent on those modules. How can your web worker access them, or can it?
Wait, can you say that one more time? So like,
Oh, I don't know. I'll just say something for example's sake, like Lodash or something.
Sure.
You're trying to do some array manipulation. I don't know what it is.
Mm.
And so in your web worker code, you want to use Lodash and then do something. How do you get access to those?
That
NPM
I'm not sure
modules?
if you would. I'd have to figure that out too. So because it exists in a different context in the main thread. So if you import Lodash,
Bigloop.js, what's in there? Because you should be able to just import that stuff into Bigloop.
Yeah,
We're in a
might-
browser. We're not in Node.
yeah,
Yeah,
I think it
right.
exists in a separate context, and I'm not sure you can import that stuff. Off the top of my head, I don't know how to do that.
Would you have to like bundle it in this file?
Maybe. Well, I don't know, because even then it exists in it's a parallel universe, the browser. So you may have already imported Lodash, but it's like it doesn't know about Windows, and Lodash would get loaded on the window object, or is it global?
And the other thing is
It'd be on window.
Yeah, window. Thank you. Yep.
Yeah, most of the work I do, it's all, you use web, you get the bundle.js
Webpack,
file.
yeah.
It's all in one.
Right.
What the heck is the thing I'm
That's
talking about?
Webpack.
Webpack,
Yeah.
that's what I'm looking for. Yeah.
Yeah.
So then all your modules are just in one JS file. So
Yeah.
Can the web worker interact with that somehow? I don't know.
I mean, you can add web worker work to that bundle, but it's still gonna be like, yeah, you'll instantiate a new one in that bundle, and it'll still file it off to the side. It wouldn't be able to like interact. The only way to interact with it is through the message queuing system, so like sending messages.
Interesting.
Well, if you can pass stuff in, you might be able to pass that in.
Sure,
through.
like a ref.
If
Yeah,
there's
sure.
a way to do it, you could pass a ref through. But
Yeah, that's true.
if you could do that,
Yeah.
you can't do that.
But it wouldn't make sense for you to pass refs because the reason why it's siloing it off is that you don't
Right.
have memory race conditions.
Mm-hmm. Those are
Yeah.
good questions. I'm not sure. Yeah, I'd have to look at that. That's a great question. Cool. Anything else so far? Yeah.
Can you make it a Regex call from a web worker?
Yeah. You totally could. Yeah, totally. You could wait for that data to come back and then fire that back to the main thread. Yeah, they totally could do something like that. I'm going to talk about here too after I talk about the future of this, like kind of what's best practices for using this. Because my thought whenever I go to a talk like this is always, I'm going to go wild and add 4 billion web workers to my code, which is probably not a good idea. We'll talk about when you should or should not use web workers. But okay, let's see here. Oops, I forgot. Future of web workers. I'm trying to do like a Big Lebowski vibe on this, and this is the most futuristic Big Lebowski. It's not a sci-fi movie. So anyway. So personally, what I think is going to happen with web workers going in the future is we're seeing more and more data-intensive and visual stuff happen in the browser, namely with WebGL and Canvas. You guys have probably seen some cool experiments down on the web. This is a Chrome experiment doing some 3D visualizations and real-time data analytics in the browser. I think we're just starting to explore some of this stuff too, and I don't think that us pushing the boundaries of what the browser's doing is going to stop anytime soon. And I think as we push more and more work onto the client and do more and more intensive stuff, I think utilizing web workers has become more and more essential for keeping the web fast. Yeah, for me, these play super nicely. There's libraries for all these stuff to like utilize multiple threads for you, which is really great. But they seem like ideal use cases. Okay, let's see here. Do I have a? Actually, yeah. Okay, I think it's at the end. We'll talk about the best practices. Recap. So, first thing. So best practices. This is kind of where we talk about best practices. Our web workers are heavy. So you may have even seen that visually with my code here, right? Like this is kind of clunky. I'm adding a lot of extra overhead with code in order to get this fancy for loop to work. Just like code readability wise, this is still a lot easier. So you're still adding additional. It can be a little heavy-handed to do work, and also web workers should not be used in large numbers. You want to, because like computers only have so many cores. Chrome is already notorious for being a resource hog. This isn't going to help at all. This makes it worse. So they should still be used. This is like, consider this like a tool that you now have in your tool belt to solve problems. If I were making applications, I wouldn't be busting this out until I started seeing performance issues on a main thread. I think premature optimization is the root of all evil. And if you're adding web workers to a problem that you're not seeing performance issues with, it's probably not a good solution for it. But if you are seeing some blocking operations, this is a great tool to bust out. You get for free with the browser. Cool.
Can I ask a question on that?
Yeah, please.
God, I'm asking so many questions.
No, it's good.
Say you have an existing app and you notice that you click a button and it gets blocked for a couple seconds or something like that. And you're like, all right, I want to do some optimization. How can you find what exactly is blocking in your current app?
Oh, great question.
Profilers built in the browser.
Yes, this is the performance tab. Let's take a look at the slow loop. I'm not mirroring my screen, so it's hard to do. But let's take a profile of the slow web app. So we're gonna and start big loop. Let's see it going.
Just thinking about it. Oh, well, you just queued up a bunch of big loops now.
It's going to do 10 big loops. No!
Well, if you hit stop, it'll still show.
Yeah, let's see what happens. You should lower that for loop down to
Remember that question about can you close Chrome when this happens?
Yeah. I did crash this a couple times as I was making these demos. Made my for loops a little too big. So let's see here. Whenever I see performance issues, the first thing I do is load up the performance tab. And if this loads up, I can show you what to look for maxing out the main CPU. And whenever you see a max on the CPU, that means you're not doing as much you possibly could. And you want to figure out how to break up that work. Okay, I don't know if this is going to work. Let's see. Maybe, okay, I'm going to do like, it's always dangerous loading that up, and you never know. Sometimes it's not safe for work stuff on there, so you never know. All right, let's do a profile. I can actually show you. We max out the main thread in bestbuy.com. Something we're currently working on, but I want to show you what that looks like. Let me close this too, just for my computer's. The fan's turning on. It's from doing a for loop. That's not a good sign. This thing's still going. Okay. Well. Yeah, maxing out all my cores.
So while you're loading all that,
yeah.
To pass in messages, it's a .post message, so it's worker.post message. You can pass in what you need to. Back to being able to bring in Lodash. Me and my phone went out of danger. Worker in Webpack, there's a thing called Worker Loader, and into that you can actually pass in all of your whatever's in Webpack. So whether you have Lodash or Object Get, or you're bringing in God only knows whatever NPM repository, you can pass that all in through here.
Awesome. No, thanks for looking at
There's
that.
a way to do it.
Great.
Wow.
That's
I don't
awesome.
know if it's any good though. Just Google.
No, that's great. Cool. This is still not loading. We'll keep an eye on this. I don't know how long this is. I may have to. Can
Force quit.
I might have to. This happens so many times writing this deck. It's Okay, well I'm gonna let this keep running, and then I'll just finish out the stack and see what is in the end too. If you're curious to, I'll probably try to demo it afterward. Try to dig in there too. But okay, cool. So don't use them all the time. One last thing I want to cover before we jump on to the end here is my last point. Web workers. Oh boy, that's right. Web workers, they're great, but be aware of the added complexity of adding multiple threads to your program. So as we mentioned, like when we talk about the advantage of single threads, a lot of times us as JavaScript developers, we're used to using single-threaded applications. And let's imagine you have a new team team member on your team that never seen your code before and doesn't realize you're using web workers. You might be giving them a nightmare trying to understand how your code works and why in troubleshooting it. Web workers, multiple threads can introduce a bunch of complexity to your application. If you have any multiple, anyone's used any other programming language besides JavaScript or Node, you can attest race conditions are no joke and can be kind of an issue sometimes. You are opening that Pandora's box. So there's a cost. I think there's a cost. Yeah, that complexity can be tricky. So.
What is the race conditions there?
No, good question. Yeah, I've been saying that word a lot. So a race condition would be like, let's see here. Let's look at code and imagine a situation here. So for example, a race condition would be if we are showing iterations here, but maybe we're waiting for this for loop to complete and it's not done yet. So you could be expecting things to be there when they're not quite there yet.
Can I take a stab at it?
Yeah, please.
So let's say when you have a program that's running, you have a single thread that's writing things to memory and reading things from memory. So let's say you have this big continuous piece of memory, even if it's just like a string or something. You have one thread that's coming along and it's got to write character by character. Okay, I'm going to put this one in, then this one, and then this one in. If all of a sudden you have another thread that's running and reading that same chunk of memory, if your operating system says, okay, you're in the middle of writing in this string, the OS doesn't know or care. So it pauses that thread, starts up the new one, and all of a sudden this new thread is going in, reading, where you have one thread reading what another thread is trying to write. That's the race condition. That's the most basic example, very simple and very easy to see how that's a problem, because now all of a sudden this thread is going along, and now it's reading uninitialized, unwritten memory. You have an improper data structure sitting right here. Does that make sense?
Yeah, it seems like the way that this is written, you would always wait for everything to be written to memory before.
And that's why single-threaded is so great.
Okay.
Yeah. And this is still we're firing off one other thread, but if you have multiple, I can maybe show you an example. Here's but it's still going. Really gummed that one up.
Kill all.
Let's see here. I want to show this example here too. This is not my work, but it's a MD5 password cracker. It's a brute force browser-based password cracker utilizing web workers. I would note, if I were building a password cracker, I would not use the browser. It's still, you're going to make a much faster password cracker written in not the browser. But this is a great demo of how to use web workers though. Because password cracking, I don't know if you know, it's pretty hard to do, right? It's intensive. But if we refresh this too, each of these workers, you can see all these workers get added on here too, and it's going to start trying to crack those passwords independently in each thread. And then once one of the workers figures out what the password is, it terminates all the rest of them.
I'm getting that status back.
Which
So
status?
the numbers when they were ticking up, how was it getting that status back? Is there another return setting?
There must be. I guess you could additional messages on there.
Push back a message.
Yeah, without terminating it. Yeah.
Oh, that's actually cool.
I love this example. I think it's obviously way more complicated than my for loop, but.
That's interesting.
Yeah, terminates all once it finds it.
So when you said it was gonna get hot in here, did you know it was because your laptop was
I did not. I should have figured. Okay, cool. Let's see here. That's it for me. So thank you so much, everybody. Thank you. yeah, again, follow me online too if you're interested. I post a lot about performance, front end, browsers, JavaScript, Node, security, whatever. I will be posting all these slides with additional resources on my Twitter too if you want to do some more homework on this on your own. That's great too. Otherwise, thank you so much, everyone. Appreciate it. I'll be around for a little bit too, answering questions, just kind of chit-chatting, whatever too. But, and trying to get a browser. Yeah, that may be a while. Let's see, I may have to try to.
Activity management. Yeah. Chrome can't cut through.
I think I gotta restart my browser here. Whoops.
Do not restore that tab.
Yeah, that's.